the session we're going to be talking about is biosolids. What are your different alternatives? Why do biosolids management? And what are different ways of going about the process? So I can figure this out. Basically, biosolids management comes at the tail end of your plant. So after your liquid line has undergone its treatment, you get into biosolids management here. And at any wastewater treatment plant, your biosolids management can contribute about 30 to 60% of the operational costs at a facility. So it's critical to address these biosolids challenges, and there's different ways of going about it. So biosolids management, as to how do we accomplish it, there's two broad categories. There is anaerobic digestion and aerobic digestion. Anaerobic digestion is essentially treating the biosolids or the sludge that's produced in digesters under anaerobic conditions, so conditions without air. Basically you try to hold the biosolids inside these digesters for an extended period of time, where the different types of bacteria act on it and convert the organics and the cellular biomass into biogas. The other approach is aerobic digestion, where you take the sludge into aerated tanks, and essentially you use different type of bacteria to oxidize the sludge components and get your volatile solids reduction as a result of that. So those are two broad categories. In terms of, so let's start with category one, which is anaerobic digestion. And looking at why would one want to do anaerobic digestion versus aerobic digestion, what are some of the pros and cons? So looking at, say, the opportunities with anaerobic digestion, the biggest one is the ability to, apart from getting volatile solids reduction, to have gas production at the facility. So which could then be used to generate electricity and manage the energy at the facility, with a goal towards becoming an energy neutral or an energy positive plant. You could also make money. It could be a source of generation of revenue by co-digestion. So bringing in food waste, substrate waste, you could actually use that to generate revenue at your facility. And of course, the energy requirements are a lot lower because it's anaerobic process, which is less energy intensive in general. However, it does present challenges. Mixing can be a challenge in these digesters to ensure all the bugs get all the right amount of food. Anaerobic digestion does produce very high strength side streams, which are very concentrated in nitrogen and phosphorus, and so that does lead to problems of now trying to mitigate that additional nutrient load which is taken to the head of the plant. And of course, storage. So now you're producing biogas, which is a great thing, and now you also need to store it to be used at a later point. So there's different ways of going about that. So under such circumstances, how can you manage anaerobic digestion? What are some of your options to, say, optimize it, to enhance it, to address those challenges and the opportunities that we're discussing? So looking at the digestion itself, on the mixing side, there are several types of mixers available. One of them is right here in front of you, which is the linear motion mixer that the OVIVO offers. The principle is basically reciprocating action by the mixer, which causes the mixing in the digester. And the key thing is it uses a very low amount of energy. You're talking a tenth or even lower amount of energy for mixing a huge digester as opposed to standard mixing systems. In terms of gas storage, you could have steel covers or membrane gas holders to do that. Now, we've looked at the digestion process itself, how do you go about it, but there are ways to even enhance it. So even get better volatiles reduction, better gas production. And for doing that, you could use different processes like the lysotherm and bioorganics, and I'll get into those details a little more. This is representing more of our anaerobic flow sheet. So linear motion mixer, as we were discussing, it's basically one mixer that's inside a huge digester that's doing all your mixing. There are major energy savings and hence OPEX savings in general for the project. and it's suitable for both new and existing tanks. As we were talking about the gas storage part, there are the steel covers, which are fixed or floating in nature, or you could use membrane gas holders to either on top of the digester or separate gas storage areas. And when we're talking about the enhancement of digestion, this is where different processes come in. There's the pre-treatment by thermal hydrolysis, which is essentially a term for, it's a big pressure cooker for sludge. So what you're trying to do is essentially crack open the cells due to this high temperature and pressure, so that when that sludge hits your digesters, it's easier to digest, and hence you can get your retention time in the anaerobic digestion is a lot lower, and or within the same volume you have much higher volatile destruction, much higher gas production. The great thing with the lysotherm process that Ovivo has in particular is that it is a series of heat exchangers that does not need steam. So it's a much simpler process with equipment that folks are already used to. So it's a much more optimized process for existing operators, which requires little operator attention, because it's fully automated as well. So you're looking at increasing your VSR, increasing gas production, reducing your sludge disposal costs, and increasing your dewatering performance as well. So that helps optimize your entire biosolids management budget. The other way of doing it, so thermal hydrolysis was using high temperature and pressure to do pre-treatment. Another way of doing it is using phagotrophic algae. Now this is a cutting edge process that nobody else is currently offering, and it's hot off the oven from the university. And what you're doing here is using phagotrophic algae to accomplish the same thing that a lot of heat and steam and pressure would do normally. In this case, the algae that we're talking about, they do not need light. It is a phagotrophic algae where you're consuming the waste activated sludge cells and converting the WAS cells into algae biomass, which is then much more easy to digest because they lack the cell wall. So as a result, it's a simple pre-treatment step ahead of digestion that's doing the same thing that thermal hydrolysis does. So it's a much simpler way of going about enhancing your digestion. You can work with existing equipment. It lowers your digestion HRT, increase your VSR. You don't need any light, so we don't have to have all those photobioreactors or anything. It's just an aerated tank. And it can be used to improve both aerobic and anaerobic digestion. So that was on the digestion side, but now we look at the opportunities. Now looking at the challenges side also with anaerobic digestion is the production of side streams. And these side streams can be very high in ammonia. They're about 1% of the flow, but you're looking at 30-40% of the load of the main treatment plant because of this. So either nitrogen or phosphorus, which could be addressed by using Anammox bacteria. So we have a continuous flow granular sludge system called the Anammopack, where you're using Anammox bacteria to treat those side streams in a very compact footprint, in a very energy efficient way, and with a very low operational cost with a very quick startup. The process is continuous flow. You have influent coming in, it gets oxidized by fine bubble diffusion, the granules being heavier settle at the bottom of the tank, and you wash everything else out. A very simple process. A similar thing that could be done is phosphorus, where on the side stream the dewatered centrate that's produced or filtrate, you're trying to, scaling can be an issue at facilities because of the screw white that's produced, especially with BioP at the plant. And what you're trying to do is you aerate the side stream to strip out carbon dioxide. You add magnesium, so you have the magnesium, and there's ammonia and phosphorus already in the influent. So you form magnesium ammonium phosphate or screw white. So you have controlled screw white precipitation inside the reactor rather than that scaling happening inside your pipes and other areas. So as a result, you're able to reduce the O&M cost at your plant, and if needed, you could recover the screw white as a valuable product. You could sell it, make money off of it as a fertilizer. The way the PhosPack works is that you could stop at just removal if you just wanted to mitigate the problem, or if you wanted to take it to recovery, you could do that as well. Another way of going about phosphorus removal or recovery is sludge-based. Right now we are working off centrate or side stream. You could do it before dewatering as well, and that's where the ELOPHOS process comes in. And what you're doing is essentially adding magnesium chloride and sodium hydroxide to the sludge, digested sludge. You have vacuum degassing to help raise the pH, and by crystallizing or precipitating out the screw white, you can recover it or get rid of it from the sludge line and prevent the scaling potential in your digestion process. And also, because of all of this, the screw white crystallization, you're also helping with the dewatering performance. So that helps increase your cake solids and helps reduce your overall your sludge disposal costs. So you have two different benefits coming out of the process. So that brings us to the end of anaerobic digestion. Looking at aerobic digestion, aerobic digestion is another way of going about biosolids management, and what you're doing is essentially aerating the sludge. And in terms of the opportunities, why do aerobic digestion? It's simple and robust. You're aerating sludge. It's very well understood. It's a simple process. You can reduce the digestion volume if you thicken it using thickened aerobic digestion processes like ceramic thickening or other processes out there. You do not need any additional treatment for side stream because you're aerating the process, so you get free nitrogen removal out of it at the same time. And of course, you eliminate odors, which are a problem with anaerobic digestion. However, there are challenges also with it because high solids mixing can be an issue. And energy demand being higher because you need to aerate all that high solids content sludge, and your footprint is a little larger. So there are different ways to address it, which we'll cover in the next few slides. Here, when we look at the aerobic digestion flow sheet from Ovivo, we have thickened aerobic digestion either by gravity thickened aerobic digestion, mechanical thickened, membrane thickened aerobic digestion, and air beam covers to cover the tanks if needed. Of course, bioalganics, the algae-based treatment, can also be used to enhance aerobic digestion and reduce the volumes further, and even thicken aerobic digestion. So that's another way of looking at aerobic digestion. One of the key things that we were discussing, the challenges with aerobic digestion, is being able to mix these thick sludge tanks. And that's where the Transmax diffuser comes in, where essentially it's a non-clog design. You have an orifice above the water, so nothing inside the sludge that you have to maintain. All you have is a little orifice on top, which you can unplug and just hose it down. So it's easy to clean. It's a very robust process that's been running for over 20 years at several plants. And so it's a very, very operator-friendly way of mixing and aerating the sludge and getting your aerobic digestion. You can mix up to 3% solids, and there's no moving parts. You could also use draft or shear tubes for accomplishing the same mixing. You can retrofit, in fact, even anaerobic digesters with the system. And again, it's a very high efficiency, high can be used for high solids applications, and has been proven to really mix the tank very well by creating that flow pattern around in your digester. Another way of enhancing digestion in general is the digestivore pad process, which is essentially a combination of anaerobic digestion followed by aerobic digestion. So there are certain components of the sludge or biosolids that are coming in that can only be digested anaerobically, but the remaining part have to be digested. To enhance your VSR, you need to do aerobic digestion, and so it takes your VSR a notch above. So by following anaerobic digestion with aerobic digestion, not only do you get higher VSR within a much lower retention time, you can also, because you're aerating the sludge at the second half, you get free nitrogen removal as well. Some of the additional benefits of such an approach is that you, of course, you're getting the 10 to 30% higher VSR, but you also reduce your screw white scaling potential as it stabilizes the screw white in the sludge. It enhances dewaterability, it reduces the odor, and it helps expand the capacity, so you can do a lot more in a much smaller footprint. Um, okay. And in terms of enhancing the aerobic digestion process, you also have the algae-based bioalganics that we were discussing. It's essentially the same algae, the same phagotrophic algae, but you're putting the tank ahead of aerobic digestion. And what we've seen is by putting this process ahead of aerobic digestion, you could pretty much half the size of your digesters. So by doing a simple step, you can get a lot more digestion capacity or increase the throughput of your plant, or build a much smaller treatment basin if you're building new basins. Another cool way of thickening the sludge before going into aerobic digesters is using ceramic membranes. We have what is called the silk tad, or the silicon carbide thickening, where you have ceramic membranes which are used to thicken the sludge, and these are like your grandmother's china. It's unlike polymeric membranes which can tear. You could pressure wash these to easily clean them, and we've been able to get very high fluxes, so you can have a very compact footprint to do your thickening rather than big thickeners or any other process. And it's very resistant to debris or any other solids that are in there, or to abrasion in general, because it's essentially one of the hardest substances known to man. And it's very tolerant to chemicals and other solids in your sludge. So a very efficient way to get about 3 to 4% solids out of your waste activated sludge, or your from your RAS or VAS. So in summary, there are different ways to go about biosolids management. There's anaerobic digestion, aerobic digestion, and different ways to enhance those two processes, and also to manage the side streams coming out of them. And as a plug for Ovivo, we do all of that. So with that, if you guys have any questions, please feel free to ask. And please feel free to stop by. It was a pretty quick presentation, so if you have any further questions thereafter, we'd be happy to answer them.